For the past 30 years, the significance of the anomalously low ortho-to-para ratios, OPRs, of gaseous water, H2O, in interstellar space has remained unknown. In ortho-hydrogen molecules, both nuclei spin in the same direction, while in para-hydrogen the nuclei spin opposite directions. Recently, however, scientists at Hokkaido University, Sapporo, Japan found that water desorbed, that is, released from or through a surface, from ice at 10 Kelvin shows a statistical high-temperature OPR of 3 rather than the lower values typically found, even when the ice is produced in situ by a known formation process of interstellar water known as O2 hydrogenation. This invalidates the assumed relation between OPR and temperature and requires a reinterpretation of the low OPRs will help elucidate the chemical history of interstellar water from molecular clouds and processes in the early solar system, including comet formation. Dr. Tetsuya Hama and phys.org discussed the paper he and his colleagues published in Science, starting with the challenges of showing that water desorbed from ice at 10 Kelvin shows a statistical high-temperature ortho-to-para ratio, OPR, of 3 even when the ice is produced in situ by hydrogenation of O2, a known formation process of interstellar water. Detecting water H2O and para H2O separately is the main difficulty in studying the H2O ortho-to-para ratio, Hama tells phys.org. Ordinary analytic techniques, such as electron or single-photon ionization, cannot distinguish them. We also need high sensitivity for detecting auto and para H2O, since only a small amount of H2O is desorbed from ice following photoirradiation or thermal heating. In addition, Hama adds, it's necessary to produce a sufficient amount, 10 to 20 monolayers, of water ice in situ on a substrate at 10 K. In their experimental setup, the researchers produce water ice by O2 hydrogenation, a chemical reaction between molecular hydrogen and another compound or element, at 10 K, but it requires 7 hours. These technical problems, that is, ortho or para state selective detection and in situ ice preparation, are the main reasons that studying the OPR of H2O desorbed from ice is challenging, and thus, the conventional proposal that the OPR is related to the condensation or formation temperature of ice has not been tested experimentally. Since ordinary analytic techniques cannot distinguish ortho and para H2O, the scientists addressed these challenges by employing the resonance-enhanced multiphoton ionization, REMPI, technique. Originally developed for spectroscopic investigations in the field of physical chemistry, REMPI allows ortho-para state selective detection of H2O by tuning the photoionization laser wavelength, and it has very high sensitivity. The researchers think that REMPI perfectly suits the study the OPR of H2O desorbed from ice, and have designed and built a novel experimental apparatus that enables both in situ ice production and REMPI detection of ortho and para H2O desorbed from ice at 10 K.